Okay, this is going to be numbers 2, 3, and 4 for quiz 4 version 1. All right, so this is the second problem. Look at it, we have one given. Okay, but this given is giving us two pieces of information. It's telling us that UW is bisecting VUX, and it's also bisecting VWX. So we have steps, reasons or justifications. Okay, so one given, UW bisects angle VUX and angle VWX. That is given. Okay, so that's our first step in the process, write the givens. Okay, second step, look for shared sides or vertical angles. We notice these triangles share a side. They share the side V or UW. So UW is congruent to UW. Okay, that is going to be reflexive property of congruence. Okay, the reflexive property of congruence. So we can put it in, put a mark on our diagram. Okay. So we've written the givens. We looked for shared side vertical angles. Step 3 in the process is to use our givens. So in this case, we're given two pieces of information. Okay, so we're going to have two steps here for each one. So UW bisects VUX. And if you look at your reference sheet, angle bisector is defined as dividing the angle in half, dividing the angle into two congruent angles. So if we have a bisector, we're dividing angle VUX into two congruent angles. VUW, angle VUW, and angle XUW. Okay. That is the definition of an angle bisector. Definition of angle bisector. And this follows directly from what we are given. We are given that UW bisects angle VUX. So if you look at your reference sheet and you read the definition, it says if you have a bisector, UW, bisecting angle VUX, then it creates two congruent angles. So in this case, VUW and XUW. Second part of our given said that it also bisects angle VWX. So again, we're going to have two congruent segments. So VWU, angle VWU is going to be congruent to angle XWU. And again, definition, angle bisector. At this point, we notice we have three congruent parts. So let's see if we can use any one of our postulates to determine if the triangles are congruent. They're the same size and shape. So again, we cover one of our triangles up. Just look at one of the triangles. Angular side, that's an angle. Angular side, that's a side. Angular side, that is an angle. So we have angle, side, angle. The angle, side, angle postulate tells us that if we have two angles that are congruent and the included side is congruent, which we have two angles that are congruent and the side that's in between them is congruent, then the triangles are congruent. So step 5 is triangle UVW is congruent to triangle UXW. And again, that is by angle, side, angle. Again, right? Given. We have one given in this case, but this given gives us two pieces of information. Okay, step 2 in the process is to look for shared sides of vertical angles. Here we have a shared side, so we're going to use the reflexive property of congruence to say that UW is congruent to UW. You could have also said WU is congruent to WU. That would have been fine. We're going to use the first piece of information given to us, right? So step 3 in the process is use the given. So we're given a bisector. So it bisects VUX. Since it bisects UVX, VUX, we know that these two angles are congruent. And then since it bisects VWX, we know these two angles are congruent. Then we have 3 congruent parts, and we see they're aligned in angle side angle, so we can use the angle side angle postulate to prove that the 2 triangles are congruent. That is number 2. I don't know why I was trying to scroll down on the computer there, but I have to deal with my awkwardness. Number 3. So steps, justifications. Make sure you can see it on the screen. Okay. So here we're given 2 pieces of information, right? Step 1 in the process, write the givens. So step 1, PQ is parallel to ST. You can make sure you're putting the bar over top of our sides because sides are segments. Okay, and our second given is PR is congruent to TR. So again, don't leave it as without the bar on top. You need to put the bar on top. Without the bar, PR, that is a distance. PR represents a number. It's a length. Right? It's the distance between points P and R. We don't want that. We want the name of the side, which is PR. Diagram already has it in for us. So PR and RT are congruent. And we know that PQ is parallel to ST. Okay, step 2 in the process is look for shared sides of vertical angles. We don't have shared sides, but we do have vertical angles. So again, R needs to be the vertex, so it needs to be in the middle. So angle PRQ is going to be congruent to angle TRS. Okay, they're vertical angles. And we know by the vertical angle theorem, vertical angles are congruent. That's what the vertical angle theorem tells us. Vertical angles are congruent. Okay, so we've written the givens. We've looked for shared sides of vertical angles. So step 3 in the process is to use the givens. Okay, so the one thing we have is parallel lines. Okay, so if we have parallel lines, we're probably looking for alternate interior angles. And if we look, we have 2 possibilities here. So here's our parallel lines, ST and PQ. Okay, we can pick either one of these 2 transversals, QS or PT. We notice we have alternate interior angles here. Okay, and let's go with those angles. So PQR, angle PQR, is going to be congruent to angle TSR because of the alternate interior angle theorem, which says that if you have parallel lines, right, then our alternate interior angles are going to be congruent. So we have alternate interior angles, we have parallel lines, so those angles are going to be congruent. We now have 3 corresponding parts that are congruent. 1, 2, 3, side and 2 angles. So we can use one of our postulates potentially. Let's see. Is this an angle or a side? This is an angle. This is an angle. and this is the side. Again, cover up one triangle, just look at the other one. So let's just look at this one triangle. If we erase these lines, right, we have angle, angle, side. The angle, angle, side postulate says if you have two angles and the non-included side that are congruent, then the triangles are congruent. So triangle PQR is congruent to triangle TSR. Okay, these two are the same size and shape. Okay, so again, write the givens, look for shared sides or vertical angles, use the given. So we're given one of the congruent pieces. We have vertical angles to find the second congruent piece. And the third piece, we are using the given. So you could have also done a couple other things. Instead of doing vertical angles, you could have used our other set of alternate interior angles. And you could have done angle, angle, side. Okay. Or if we had chosen here, instead of using these alternate interior angles, to have used these alternate interior angles, we would have had angle, side, angle. And then we could have used angle, side, angle to prove that the triangles were congruent. So this one, there were actually three different ways we could have approached it. Write the givens. Two givens, write them. Look for shared sides or vertical angles. We have vertical angles. Use the given. Parallel lines, you're looking for alternate interior angles. Here we had two options with our alternate interior angles. And then cover one triangle and see which postulate you have. And the way we did it, we had angle, angle, side, but we could have done it differently and got angle, side, angle. All right, number 4. So, number 4. We see the whole. Steps. Okay. Step 1 in our process here is to write the givens. We have two givens in this case. So one, they're telling us which is that Z is the midpoint of XY. Okay. Again, I'm abbreviating midpoint with MP. If you abbreviate, that's fine, but don't just write Z then XY. You have to say what Z is, how it's related to XY. Z is the midpoint of XY. You don't have to write out midpoint. You can abbreviate it like I did, but I need to know what you're talking about here. You can't just say Z XY, because that's not going to tell me enough information to understand what you're trying to say. Okay, the second given is coming from the diagram. Okay, these hash marks tell us that WX is congruent to WY. Both of these are given to us. Okay, so step 1 in the process, write the givens. Step 2 in the process, look for shared sides or vertical angles. Okay, we have a shared side. Both triangles have side WZ. So WZ is congruent to WZ. And that is the reflexive property of congruence. It is equal to itself, or congruent to itself. Okay. So step 1, write the given. Step 2, look for shared sides or vertical angles. Okay, let's fill in our tick marks for that one. So put 2. Step 3 in the process is use our given. So the given we got from the diagram, we already have congruent pieces, so we don't need to do anything more with that. Okay, so let's use our given that does not have a congruent piece, which is that Z is the midpoint of XY. So again, Z is the midpoint of XY. So the definition of a midpoint says that it splits this segment into two congruent segments. So Z is splitting XY in half, So xz is going to be congruent to yz. Xz is congruent to yz. Put our hash marks in. All right, we now have 3 congruent parts, so we can look to see if one of our postulates is going to work. And let's cover one triangle up. Is this a side or an angle? There's a side. Side or angle, that's a side. Side or angle, that is a side. So we can use the side-side-side postulate, which tells us if we have 3 corresponding sides that are congruent, the triangles are going to be congruent. So if you take those 3 sides, try to rearrange them and form another triangle, you can't. The only triangle you can form is one that is the same size and shape as this one. So side-side-side tells us if we have 3 corresponding sides that are congruent, then the triangles are congruent. WYZ is going to be congruent to triangle WX. Okay. So write the Gibbons, look for shared sides or vertical angles, use the Gibbons, and then use one of our postulates to prove the triangles are congruent. Okay, that's the first version. If you had this version and you want to look at the proofs for the other version, you can certainly watch that video as well.